What sparks innovation? Is it thinking bigger or smaller? Does it strike fast or slow? Is it a flight of fancy or a stroke of genius? Innovation is everywhere, on desktops, in pockets, on wrists, in us. Innovation answers big questions, finds inspiration anywhere. It connects great minds, imagines the impossible, and propels us forward. At Keysight, innovation inspires us, fuels us to redefine precision in measurement, to surface insights, to remove barriers so the next stroke of genius is yours. We are Keysight. We accelerate innovation.
Dear colleagues, we start section number 3. The first speaker is Aleksandr Ridel from Novosibirsk State Technical University. He introduces online repository.
Dear colleagues, I'm glad to welcome you. Let me present my report about experimental study of partial discharges in bubbles exposed by X-ray radiation. Diagnostics of high voltage equipment is important to prevent accidents and identify defects at the early stages of development. Partial discharge monitoring in power transformers is one of the most effective diagnostic methods. Bubbles, due to their low electrical strength, can cause the breakdown of the insulation gap. Therefore, the study of the mechanism of starting and the development of partial discharges in bubbles is an actual task. This study aims to identify ways to initiate partial discharges in free floating bubbles. To solve this goal, the following tasks were formulated. First, modernize the experimental setup by adding an X-ray source. Second, conduct a series of experiments using different lead plates and analyze the results in process. Firstly, I'd like to say a few words about the experimental setup. The experimental setup was located in a grounded high voltage room in a basement at a depth of 2 meters below ground level. The housing of the high voltage room was made of 1 millimeter thick sheet steel. Inside were high voltage transformer, experimental cell, high-speed video camera, X-ray and light sources. A schematic representation of components of the experimental setup is shown on slide. The X-ray source was installed along an axis located at the angle of 45 degrees to the video camera axis, so that X-rays passed along the plane of the electrodes. Experimental cell consists of cell body, high voltage electrodes, glasses for optical registration, and fluoroplastic bolts. Now I'd like to say a few words about how we came to using X-rays in our research. When conducting research on the registration of partial discharges in gas bubbles, it was noticed that partial discharges in bubbles developed extremely rarely in only one bubble out of 40,000 bubbles. In this case, the waiting time about 8 hours in the absence of X-ray radiation. In the picture at the top of the screen, you can see a partial discharge. This can be understood by the fact that after all the partial discharge, the bubbles is elongated. In this case, it's split into two bubbles. As you can see in the lower figure, partial discharge developed in all bubbles at the same time. There is no waiting time. This is case of using X-rays radiation. We assume that the use of radiation makes it possible to create an axis of initiate electrons from which a partial discharge begins. Further, we decided to investigate the influence of the X-ray radiation intensity on the probability of the development of partial discharge. For this, we used shielding lead plates with a thickness of 2, 3, and 4 millimeters. The exposure time to radiation in one experiment was 40 seconds. In total, 20 experiments were carried out for each case. You can see the results in the table on the screen. Data is currently being processed. In conclusion, I'd like to say that the future that the data obtained will be used in a mathematical model to access the probability of partial discharge ignition in free-floating helium bubbles at various amounts of X-ray photons. This is important for diagnostics of high-voltage equipment. Thank you for attention. I'd like to answer your question, dear colleagues.
Okay.
You hear me?
Thank you very much. Yes, we hear you. If you have a question, you can raise your hand. Oh, your report was so interesting. So
it's good. Can I tell the last word? If you have interested question, and you can contact me by email in this slide.
It is.
If you want.
It is very good that our guests, your colleagues can connect with you and ask all questions. So thank you. Yes, thank you. That's all. Thank you, Aleksandr.
Thank you.
Goodbye.
Kristina Elunina from Binsk. Kristina?
Good afternoon, ladies and gentlemen. First of all, let me thank you all for coming here today. The subject of my presentation is influence of ultrasonic treatment on the microstructure of particles of detonation synthesis nanodiamonds. In this slide of my presentation include the main parts of the report. Detonation synthesis nanodiamonds are widely used in technological application. For the synthesis of detonation nanodiamonds, the energy of the blast wave is used during the detonation of the charge. The starting material for the formation of diamond particles is carbon contained in the molecules of explosive. For example, TNT with RDX, DND on, or in changes of RDX with graphite, Galan. The unique properties of detonation nanodiamonds are determined by their microstructure in combustion with nanosizes. Such nanodiamonds have a high defect density, an active developed surface, and an excess enthalpy of formation. Ultrasound is a known technique for reducing the size of brittle particles in liquid media. Cavitation is the main factor affecting the physicochemical properties of particles during ultrasonic treatment of suspension. When cavitation bubbles collapse near the particle surface, pressure pulses with an amplitude of several tens and hundreds of megapascals that are generated. This facilitates the wetting of the agglomerates with a liquid, the degassing of their fragmentation. In addition, ultrasonic treatment produces chemical effects due to the high pressure and temperature when cavitation bubbles collapse. Rapid heating in combination with compression creates high local temperatures and dissociation of all chemical bonds, including N sub 2. Gases and vol- um, gases and uh, volatiles inside the bubble can participate in primary sonochemical reaction. In this case, thermodynamically unstable phases are formed. Then secondary sonochemical reaction can take place with the participation of the products of primary reaction and free radicals. Earlier, we experimentally established that ultrasonic treatment changes the size of nanodiamond agglomerates. However, to use nanodiamonds in new technological application, it is necessary to control not only the size of the agglomerate, but also all the characteristics of the particles. In particular, microstructure, specific surface area of particles and excess surface energy. The purpose of this work is an experimental study of changes in the microstructure of nanodiamond particles of detonation synthesis as a result of ultrasonic treatment. We studied samples of detonation synthesis nanodiamonds obtained by the detonation of TNT with RDX DMD and pressed charge of RDX with graphite DALAN. According to IR spectroscopy and polarography data, the nanodiamond surface is saturated with hydrocarbons functional groups and carbon structure contain hydroxyl, carboxyl and carbonyl groups. The carbon content in the D&D samples is on average lower than in the down samples, and the oxygen content is higher. In the Darwin samples, nitrogen is completely absent and hydrogen is almost completely absent. For the ultrasonic treatment of aqueous suspension of nanodiamonds, we used the Valna M apparatus. The processing frequency was 22 kHz. The intensity was 7,100 watts per square centimeter, and the processing time was 10 minutes. We investigated the phase composition and microstructure using X-ray diffraction analysis on an XRD 6000 diffractometer. Determination of the particle size distribution of the obtained suspension was carried out using an Olympic Omega optical analyzer. The figure shows a typical particle size distribution for a D&D sample before sonication and after treatment. The size distribution of D&D agglomerates in an aqueous medium ranges from 0.5 to 7.5 micrometers. During ultrasonic processing, the agglomerate break up. Therefore, the size of the process diamonds in comparison with the original are reduced, while the specific surface area of the particles in the samples increases. The size of microcrystallites of Dalan samples are almost 2 times larger than DND, while the specific surface area differs by an order of magnitude downward. DND particles are monocrystalline formations, since the sizes of microcrystallites approximately coincide with the size of the particle calculated from the surface specific area. Dalan particles are polycrystalline with the size of particles I'm sorry, Dalan particles are polycrystalline formation collected at the stage of synthesis from crystallites of uh, 8-9 nanometers into particles determined by the specific surface area of 65-70 nanometers. After sonication, the crystalline size decreases for DND by 6%, for Dalan by 20%. The degree of crystallinity for the samples does not exceed 13%. Therefore, DND and Dalan contain amorphous amorphous phases. The proportion of
Recording in progress.
uh, the proportion of the amorphous phase after treatment increases, especially for Dalan. The specific surface area of DND particles decreases by about 12-15%. It can be assumed that the process of formation of spatially organized structures of a higher order, anion structure, take place during ultrasonic treatment. On the other hand, the specific surface area of Dalan particles increases during sonication, which can be associated with the destruction of polycrystals without the formation of new spatially organized structures. The lattice parameters of DND and Dalan are approximately the same, but in comparison with nature diamond, the crystal lattice of the studied samples is compressed, and that is, it has defects. In this case, microstresses of the second kind for Dalan are less than the DND. After sonication, the microstresses increase, especially for Dalan, by 63% compared to the initial state, for DND by 14%. The stored energy density W is proportional to the square of the stress and inversely proportional to the elastic modulus of the substance E sub U. This means that after sonication, the surface energy stored in the particle increases is in proportion to the square of the stresses, especially for Dalan, by 155% compared to the initial stage, for DND by 31%. On the other hand, the surface energy for DND particles is higher than for Dalan particles. Such a significant increase in surface energy seems promising from the point of use in new technology. The work investigated the parameters of the microstructure before and after sonication, of aqueous suspension, of nanodiamond powders, of detonation synthesis of two modifications, single crystal DND and polycrystalline Dalan. Thus, it should be concluded that the presence of excess surface energy in detonation synthesis nanodiamond particles will allow finding new areas of technological application and the possibility of further increasing this energy ultrasonic treatment opens up even wider prospects for using this unique material. Thank you for your attention.
Okay, and do we have questions to Kristina? Oh, yes.
Some questions, please. Gennady Evtushenko.
Okay.
Please show slide number 11. Microcrystalline science. What's the dimensions? What's the H and M? D, H and M. What that means? Microcrystalline science, D, H and M. What is this? H and M. What it means?
Nanometers.
Nanometers. Okay,
Nanometers.
okay, okay. Another question. How do you measure the size? How do you measure? What's the method?
Microcrystalloid.
Yes.
I think it is by X-ray method, but I don't know exactly. It is the responsibility of our.
Yes, it was the question. It was the question from Zoom, and I think this man he didn't hear us. Excuse me. Okay, I think he don't. But I know that we have a question from our audience. Yes. Okay. Here you are.
Okay. So I have a question about lattice constants. What method did you use to measure it?
This is the responsibility of our co-author. We don't know exactly. Так, сейчас.
One more question.
My question, can you tell me about your frequency supersound that you use in your setup?
22 kilohertz. Frequency of treatment was 22 kilohertz. Okay? Do you hear us?
Can you repeat your answer, or we should repeat our question?
The frequency was 22 kilohertz.
Okay, thank you very much. Okay.
How long of ultrasonic radiation we use in this research?
10 minutes. 10 minutes.
Any question? Oh, okay. One more question.
What is scientific significance of your study, and what's its application of nanodiamonds particles?
The application of nanodiamonds could be, for example, as absorbent where the exit energy is very important. And the significance of our study is that ultrasonic treatment can increase it is important we
Okay, thank you for your answer. Is it good? Okay. Thank you for your presentations. Yes?
Thank you.
Thank you, goodbye. Goodbye, thank you.
He repeats instead Shurgin.
I sent my greetings to all the participants and guests at the conference. I will present you a report on the topic ultrasonic non-contact diagnostic of the surface of burning aluminum nanopores. High energy materials are materials that are designed to generate energy that can be used for various purposes, such as providing engine thrust, scattering parts of a special object, generation light and sound effects, care airbags, squeaks, and local heating of electronic components. In this regard, the combustion of energetic materials is a way of research in which it is important to understand what happens to the substance directly during combustion. The technique or real-time study of combustion can be divided in several groups. It's study of the flame propagation, study the surface change, study of brightness and temperatures, study of components transformation. Flame propagation is typically studied using high-speed cameras. This technique does not allow imaging through flame. High-speed video recording with laser illumination allows surface imaging in part. This works is first where the problem of energetic materials studies through flame were started. This is a photo from our labs. Using the method of laser illumination, the bright lightning is partly eliminated, but the method does not suppress bright lightning fully. Full suppression of bright lightning is possible with laser monitoring, with brightness amplification. We will discuss the more detailed tomorrow in a separate report. Changing of the materials composition can be studied using synchrotron radiation. All the mentioned method of studying energetic materials we use in our research group. The purpose of this work was to develop a method for ultrasonic diagnostic of the combustion process of energetic materials. The aim of the work first is the tools for studying the dynamics of combustion of high energy materials in real time and not numerous NOs. Ultrasonic methods are relatively cheap and compact compared to methods based on optical and ionizing radiation. Ultrasonic control methods still are not used for studying the combustion process of nanopowders during combustion, and the ultrasonic non-contact methods allows us to investigate materials with an uneven surface, such as metal powders. The experimental scheme includes 3 types of research. It's basic ultrasonic, consisting of the element 1 and 6, registration of the integral brightness of the sample by the photodiode, with simulation recording by the oscilloscope 6, and high-speed video recording 9. Laser initiation of combustion 7 is synchronized with the start of the high-speed cameras recording and the start of the ultrasound examination. A sample of aluminum was investigated, pressed in the form of a tablet with a diameter of 10 millimeters. and mass of 3 grams. Its experimental results, oscillograms and M-scans obtained in the MATLAB software shows the change in the temporal characteristic of the ultrasonic signal during the combustion of an aluminum nanopowders. Conclusion, it has been experimentally demonstrated then when the surface of a burning aluminum nanopowders is irradiated with an ultrasonic wave and its subsequent registration, a change in the oscillograms of the reflected wave in observed. The observed changes using ultrasonic correlate with the data of measuring the integral luminescence brightness of the photodiode and visual observations. The results obtained in good agreement with the known regulators of the combustion of aluminum nanopowders in air. This developed experimental technique for diagnostic the burning surface of an aluminum nanopowders, thus make it possible to qualitatively control the process occurring in it. Thank you for your attention. Please, questions?
Thank you for your report. So you said like a good agreement, but you didn't really describe all your results. So you didn't show and indicate some frequency, especially you didn't describe oscillograms. Please, we need some description of your results. Thank you.
Thanks. It's oscillograms shows flame brightness and combustion wave.
Thank you.
My question, do you have a patent of experimental technique?
No, it's the started experiment.
Oh, okay.
The started phase.
I think it will be good patent.
Okay, thanks. Okay.
Thank you for your presentation. I have a question. What is the distance to the object from the receiver and transmitter?
Receiver and transmitter located on 20 centimeters for object study.
I think maybe the last question, yes or no? Okay.
So I have a question too about this for oscillogram. Can you describe the difference between them? So I see you have 4 different oscillogram on the left side. Yeah, and can you tell me in simple way what's the difference between them?
Please repeat the question.
So you have 4 figures on the left slide on the left side on the slide. Yeah, and I want to hear what is the difference, main difference between them, the first, the second, the third.
Its oscillogram shows different phases of combustion materials. It's in first time initiating materials and wave. Yes, wave propagation. Thanks.
That's all questions? Okay, thank you very much for your presentation.
Three is Jianglei Chang.
Hello everyone. My topic is bilateral filter for small angle ultrasonic tomography using London area. This article describes the small angle ultrasonic tomography using Nanowires. A bilateral filter is used to improve the quality of the tomography imaging reconstruction. The use of a window on the model is studied and tested on the experiment date. The results of modeling for one reflectors located in the testing zone are presented, and the resolution of a system consisting of receiving and exciting line areas with 16 elements is determined. So composite materials are widely used in aerospace and other industry fields. At the stage of production and use of service, the likelihood of defects or damage is very high. These defects often don't show visible marks on the surface and material, but there are defects such as fiber breakage and delamination within the material, which significantly reduce the load carrying capacity of the components and cause the latent danger of major engineering accidents. The shadow technology of ultrasonic non-destructive testing, also known as the slow transmission method, has higher sensitivity and noise immunity, and also has no dead zone compared to the pulsar method. The sound barrier wave and geometric acoustics can be attributed to the study of the diffraction of sound waves. The sound pressure of each receiving point in the diffracted sound field is obtained by solving the wave equation within certain boundary conditions. The earliest solution to wave theory are based on the Huygens-Fresnel principle and as the main starting point, and the Hermos-Kirchhoff integral theorem are based on the Green's equation. The sound field after diffraction is small, therefore it can be considered as a acoustic beam. To determine the coordinate of defect, which is in the shape of a disk, the author proposed to apply linear acoustic areas in the slow transmission method. The reflector as a defect is located between the two ultrasonic receiving and transmitting areas. The data matrix consists of m squared measurement value. M is the number of sensors in the linear area. As we can see from figure 2, we can get coefficient K from for detection of defect. The algorithm for reconstruction of the test zone is shown in figure 3. And the simulated result and the experimental result both prove the advance of bilateral filtration, which reduce the errors. And this is experiment setup. So that's all. Thank you for your attention.
How many elements of array did you use in the experimental setup, and what is the uniformity of this element? Are they similar, different? If different, how much they are different?
We use 16 elements, and the uniform is same. The uniform of elements are same.
More questions? Okay. Okay.
What is the noise to immunity ratio for your experiment, and how do you optimize it, minimize it? Signal to noise ratio in your experiments.
It depends on the window of filtration. But in our in our experiment, it's about two or three times.
Okay. Oh, one more question.
Can we use this filter for traditional tomography?
Yes, of course. We can use it.
Okay, so thank you very much for your report, for your presentation. And now we start section number 6, yes? Okay.
Dear colleagues, we start section number 6, and first reporter is Vladimir, Generalov. Please, Vladimir.
Dear friends, I prepare a presentation about indication of the coronavirus model by Nanowire biosensor. I know I have a limit time for my presentation because I will be restrict presentation. But this picture, I won't say every day we listen and look information about COVID number 18. First diseases was last year in Wuhan of China. In March, World Health Organization announced about COVID as pandemic. Pandemic is the highest form of epidemic. It affects all people, our planet. In our history, we have last century 3 pandemic at 1857 and 68. Flu pandemic 18 year. Our losses was from 2 million to a million. 20 million and more, 100 million pandemic, 58 and 68 have 1 million people killed too. We understand now the losses from this one pandemic will be great too. I have problem.
I want to say that you have lots of time. You're like a plenary session, so you have all time.
Okay, thank you. World Health Organization have a task about diagnostic and equipment diagnostic and laboratory diagnostic, because we want, as people have result diagnostic after 10 or 15 minutes. Now we have 2 means method for diagnostic coronavirus. First method, it is polymerization chain reaction. This method search virus into our organism. Next method. It is method ferment analysis. This method search antibody of coronavirus in our blood. First method is second method. Release after 30, maybe 40 minutes. But I won't repeat. We won't have result after 10 or 50 minutes. My presentation for engineer is student of technical education, because I sometimes say population world. What? Туда надо, да? Sorry. In our job, we develop field effect transistor biosensor as device for indication virus. By Russia, field effect transistor, it is полевой transistor. Our field effect transistor, we have new, maybe for transistor, phenomenon, fundamental phenomenon. For develop our device, we must have a theoretical knowledge, method, and way for measurement, develop of special solution, control system, calibration, and training personnel. Yeah, I think you understand coronavirus is virus have big problem our health because training personnel. Here I want to show fundamental effect interaction particles with electric field. Here I show dynamic my film. Dear friends of engineer, I want dynamic my okay video. It is real time. Area black area it is electrode and between electrode we have non-uniform electric field, and we can see reaction cells to electric field when frequency are 1 megahertz. Our conclusion: biological object interaction with electron field. Next, here we can see frequency 100 kilohertz, and particle move from electrode, and it is fundamental phenomenon also. Now we understand particle absolutely any particles interaction with non-electrical field too. Cells and virus have three main components. It's membrane, capsid, cytoplasm, and genetic apparatus. The membrane is complex of molecule and thickness 10 nanometers. Membrane have potential about 50 millivolts. Capsid of virus have We can see capsid of membrane, also membrane. Cytoplasm is a combine of structure, protein, genetic apparat, and other particles. If we have problem in pathology change into our cells, we understand it is diseases. Here you can see our equivalent electrical phoresis and equivalent electric scheme of cells. A red line, it is a membrane. Yellow square is cytoplasm, and we have also, and we have also electrolyte. Membrane capacity and electrolyte, we have resistant capacity too. Here you can see erythrocyte of monkeys without pathology. I think it is a very good form. Here, building number 8, where is my laboratory. Erythrocyte after interaction with flu virus. You can see another form, and we can see also building number 1, where we have a study with coronavirus. Here we can see our friend who will be building number 1 and the rest too. And another picture, you can see our device as a microchip for diagnostic coronavirus. This area is a crystal of microchip. Principle of biosensor. It is here. It's source, the rain, this gate of a transistor, this electrode of electrophoresis, and here line it's second gate. When we switch on non-uniform electrofield, we know virus and antibody of virus move to electrode of lateral electrodes, and in this area we have more concentration virus because we have good results for sensitivity our biochip. It is a picture. You can see sorry, не туда. You can see one transistor. Here, source, drain, it is lateral electrode for the electrophoresis, and this place is gate number 1 and nanowire. it's a topology of our biosensor. Here we have 40 transistor. It is topology have a good sensitivity for our experiment. If we have a small concentration virus, our electrolyte. What is antibody antigen? Antibody is protein production by cells, plasma, and response in infiltration of antigen into the body. Antigen is a substance that the body examines as dangerous. Here you can see coronavirus and this antibody and interaction between antibody and coronavirus. Here you can see our result. Y line is current of Dray. X line is experimental time, and we have two experimental line. A red line, it is experiment at black red line, it is control. We can see control experiment. In suspense, the virus is absent. Experiment, red line, we have virus into the electrolyte. Conclusion. We have next fundamental phenomenon. First, effect antibody plus coronavirus particles complex modulate current field effect transistor. Next conclusion. Particles virus have electric positive charge on the nanowire surface. Antibody plus coronavirus have a negative charge, and our sensitivity was one virus in experiment. For indication, we use only 200 or 300 seconds. But you remember World Health Organization won't see this parameter about 10 minutes. Thank you. Welcome to Vector. Question?
So, thank you for your presentation. I have several questions. Can you show a slide with a current versus time figure?
This?
Yes. So in field effect transistor, we can measure current versus gate voltage dependence. So can you explain again how you conduct your experiments? What gate voltage do you apply and how it depends on some cells?
Our experiment have next stage. Understand that? First stage, we switch up non-uniform electron field, and after 1 minute, we switch off this electron field. Next stage, we switch on voltage on the drain. This volt 0.15 volt we have on the drain. Then we, after it, registration our current of our biosensor.
So you apply a voltage between source and drain? Or what?
Yes.
So why do you need a field effect transistor in that case? You could just use simple capacitor or something, because the main point of field effect transistor is gates, and we can like.
Okay. This area is a drop of virus electrolyte, and this electrode is a reference in our virus electrolyte have potential 0, because we understand only information and about virus when it state this position on society gate. You understand?
Well, not clearly. I can ask you later. And sorry, it's just one simple question. In the beginning, you tell that when we change frequency, some cells are attracted to electrode and some cells goes away. And which kind of interaction it is? It's Coulomb interaction or it's different, some kind?
We have the same experiment, and we read about result in another article, because we understand move cells and virus in non-uniform electric field. Maybe virus move two electrodes, maybe that attract for electrode. It is a result of our experiments. We understand frequency for virus.
Okay, thank you. Next question.
Please, tell me.
So thank you for your presentation. It was very interesting. But I have some questions for you. The first question: is this study was in vitro or in vivo? So in vitro means in the test tube. So in vivo means in the organism, in the patient, for example.
It's a result in vitro.
Okay.
And we have a special solution. We use distilled water and glucose or saccharose 5 millimole.
The second question, if I can ask you, you said about type of blood cells which can be affected by different viruses. Also, in your example, it was an erythrocyte. It is influence of virus influenza to the erythrocyte. Tom, please, why did you take an erythrocyte, not an macrophage, not an platelet, or something else, cells of the blood system? Thank you.
Big question. We have experiment, I say, as in vitro with virus influenza, virus coronavirus, and we have a result interaction with another virus, example, Krasnucha. And I can say absolute no particle and absolute no virus polarizability and have characteristic dipole moment, induced dipole moment, because the particles move to electrode or from electrode.
Thank you for your answers.
Okay, and I think the last question from our hall, and we will listen the question from Zoom. So please wait.
Thank you for the interesting talk. The question, so is it possible to create a device which can distinguish different viruses?
Yes, because we understand constant interaction between virus and antibody for this virus is very high. Because if we have antibody, we understand what is the antibody. We understand what is the virus, is the suspension or electrolyte. It is basic in this device and experimental.
The last question, Zoom. Hello. Do you hear me? Okay, no, goodbye. Okay, one more question from our audience.
Vladimir Mikhailовich, thank you for your report. So what is, as I understood, you already register such biosensor, or it's just in process? I mean, I'm talking about registration in Ministry of Health of Russia Federation.
It is a very difficult procedure. I think total cost of this procedure may be 1 billion ruble, maybe more.
I'm not talking about money, I'm talking about so you already start the process of registration?
No.
No? Okay. And what is the accuracy of this biosensor? Did you check this? Accuracy.
I have no answer.
Okay. Thank you.
Okay, thank you very much. I think that's all.
You are explorers. It's who you are. You think bigger and smaller. You think faster and slower. You take inspiration from everywhere so you can innovate more. Your visions start in rooms, move to desktops, then to pockets, then to wrists. You ask big questions, pose impossible challenges, all the while seeking those who believe like you do. At Keysight, we believe. We nurture the far-fetched, remove barriers that limit possibilities, and stay ahead of the standards. We redefine precision in measurement so you can go smaller. We integrate and expand test functions so you can streamline complex workflows. And we surface intelligent analytics so you can innovate faster. We believe in you. We are Keysight. We accelerate innovation.
Alex, next
Hello, my name is Lidiya. I'm the engineer of Metrologic Institute. I'm going to present your project entitled Research for Primary Reference Bioparticle Polarizability Measurement Procedure Development. Nowadays, development of medical diagnostics equipment prototypes what would help to study characteristics of biological cells promptly and at minimum expense is quite relative. The most promising approach to study microparticles is based on the electrophoresis method. Measuring and community system implement the electrophoresis method effort measuring polarizability, hardness, viscosity, electrical capacity, conductivity, and other properties of microparticles. Now, on the complex of the specified property specific what helps to estimate the state of the biological object under study. For this purpose, the reference bioparticle polarizability measurement procedure was developed in order of improved the accuracy and objectivity of measurement obtained using the electrophoresis method. Instruments of metrological support for measuring biological particles and cells electrical polarizability must be used. The primary reference measurement procedure is based on diffusion and is implemented as an in the equipment complex. The flowchart of the complex is given in picture 2. Measurement uncertainties can be used as the measurement procedure accuracy indicators. Studies of metrological characteristics of the primary reference bioparticle polarizability measurement procedure were conducted on the basis of experimental data obtained using the equipment system for the procedure implementation. Macro-size polystyrene particle were used as an object imitating bioparticles. We conducted the experiments similar to those done for validating the accuracy of the reference bioparticle polarizability measurement procedure. The measurement result of the radius velocity and polarizability of the particles radius velocity and polarizability measurement results are given in the following table. The relative standard uncertainty of a type was determined for arbitron and certain factors, microparticle radius and velocity. After then we conducted calculations of the relative standard and setting estimate by type A basing on the data for the table. A type relative standard uncertainty is calculated by equation and is equal to 0.031. B-type relative standard uncertainty is calculated for systematic uncertainty factors distilled water viscosity, voltage between electrodes, distance between electrodes. B-type relative standard uncertainty is 0.042, where relative combined standard uncertainty is 0.052. Relative expanded uncertainty is 0.143. According to the standardization recommendations, the first signification digital was rounded, and we got the value of 0.15. The update value of the relative expanded uncertainty is in the agreement with the values update while the conducted research within of the primary reference bioparticle polarizability measurement procedure. This result is confirmed by the relative expanded uncertainty value obtained within the primary references bioparticle polarizability measurement procedure. Presently, we continue to study the possibility of estimate bioparticle characteristics in the field of ultra-high frequencies. Thank you for your attention.
Okay, thank you very much. Any questions? Okay, thank you.
Can I have my idea?
Yes, of course.
Dear friends, maybe you know in metrology we use in metrology we use ampere. And now we have in our country another device for the Bilateral. And we have methodology for calibration of our device. It's very important step for this device, and you can make our example a lever. Thank you.
Okay, thank you very much.
Reporter is Alexey Zhdanov.
So today we're gonna talk about our project. Our project called Oculosgraphy, which means oculus is our eye, and graphy it's like electrocardiography, like this thing. So it's something which we can measure, analyze, process, and so on. So today we're gonna talk about retinography. So it's a signal which is recorded on the retina of eyes. So our project collaborator is Ekaterinburg Center of Microstructure. And the first electroretinography may found in works of English scientists, which is Scottish originally, James Dewar, and he realized the first record in 1977. So on the image we can see the typical electroretinography signal. It consists of a few components. The first one is A wave, which indicates A, and B wave, which indicates B. So the main parameters is amplitude of A wave and B wave, and also latency. It calls latency, but actually it's the time between the start point and the low level of A wave, and so on. So first of all, I want to describe electrophysiological source of such signal. If you look at retina structure, then we can see that human or animal's retina consists of many cells and cell structure. Here is electrooculography signal. So it's given by muscles of on eye. And this is the physiological driver of the signal is retinal pigments. Then the next level of cells is cones and rod cell, which is here it marks the red. It has red marks. Then another components of electroretinography signal is marked by blue. It has blue marks, so it's given by amacrine cells, and the green one is Müller cells. So, and then if we look at other structure, at other signals of electroretinography, then we can make some, separation of its signals, which is getting during dark adaptation, light adaptation. So also we have some difference of light intensity and so on. But today we are talking about maximum electroretinography response. In other case, it's not enough time. We have published a database on December 16 last year, and our database consists of three types of electroretinography signal. It's scotopic, so it's getting by dark adaptation, the maximum what we're talking today, and the photopic, so it's the signal which is received, which is getting by light adaptation. And here you can see the signals limited, which was determined by the manufacturer of electrophysiological equipment. We used the German equipment. It calls Tommy, manufactured by Nürnberg company. And so what is the standards of electroretinography? So this is International Society for Clinical Electroretinography of Vision. And according to the standards, the signal should be filtering by a posteriori methods. So what is it? What is it? So it's not just linear signal. We have to analyze which filter is better, and in this case we have to look at the signal on FFT transform and so on. So let's start. So here on this image, on the left image, you can see the input signal. As I showed before, it consists of several components: A wave, B wave, and as we can see here, the peak to peak amplitude is approximately 95 microvolt. And if we look at FFT transform, then we can see the power. Here is the frequency, and here is amplitude. And the power of signal is concentrated in range from 0 to 40 hertz, and the maximum is from 0 to 10 hertz bandwidth per. So what we did, we used a Gaussian noise, so with controllable amplitude, and the noise signal was selected as 0.1 ratio step, and maximum noise was 90%, and we have choose the low pass filter, the best one. We compare Butterworth, elliptical, Chebyshev first and Chebyshev second filter, and the filter, we have several orders of filter from 1 up to 4, and the cut-off frequency was 50 Hz based on previous FFT analysis. And if we look at standard of International Society of Electrophysiology, then we also may find the range from 30 to 50 Hz up to equipment which you use. And the best one was the second order Butterworth filter and second order Chebyshev first filter. And it filters the signal in the best way according with the correlation analysis and the noise level, so we can clearly analyze the signal, clearly filter the signal during noise level up to 50%. And here we can see the coefficient of our filter, so which we can put into this formula and then define the better filter methods. So that's all about filtering of electroretinography signals. So actually I have a few reports, so if you wish I can tell you next one, and or questions, so up to you, where we want.
We can ask the question to this report now, or we can listen the next report and ask. Okay.
Well, I think here we have one question. Yeah, they are related. Yeah.
Okay, so the next report. Maybe. Okay.
My question, do you have this method as a medical device in our medicine, in our country?
Okay, that's a good question. So I think I have to move to the first slide. Even here it's okay. So here this is the input signal, yeah? So how we record the signal. We need some room, the dark one, with light switch, and we also need some light sources. Usually it's diodes with setting intensity of light. Then we have to localize the patient face like this, or just put on some some issues. Then we should connect electrodes. Sometimes it's some lens, or it's electrodes which is put in under this soft tissue, and during light stimulation we record this signal. Yeah, and at now moment all the medical company or microsurgical centers used German medical equipment, or it calls Tommy, it's the same which we used, or Roland equipment. And in Russia we have several companies which produce electrophysiological equipment. It's Neurosoft company. Actually all the parameters are the same, but doctor prefer German or United States equipment because they have they have some background in this field. So our study is actually not about equipment, it's more about software. So we have to all the signals in Roland and Tommy equipment, it's like we have to decode this. So we have some partners in Moscow Power Institute, and some research group already decoded a signal for us, and then our aim is to analyze these signals for medical purposes. So at now moment, all the clinicals, they just analyze signal by A wave and B wave, just amplitude and latency. But we want to implement, you know, advanced analysis, which will be in next presentation.
Can you show the next presentation? Oh, no.
Yeah, I have.
Please.
So it's the next one.
Oh, okay, okay.
So I prepare just one presentation for
Oh,
my
okay,
topics.
okay. And after this presentation, we will ask all questions, okay?
So the next, I mean, we have at now moment we have several problems. So we know, as I showed before, we have some parameters for adult patients. But if you look at scientific literature, if you search for some pediatric standards, that's really difficult to find. It's sometimes it's up to equipment, and you know, the pediatric norms. It's difficult to define pediatric norms because the cell. The retina cells is changed, month after month, and all the interaction is different. It's getting so also in accordance with the requirements of International Society for Clinical Electrophysiology, all the signals should be rated with specified format. So we have to define median signal, so median value, and standards deviation, and also 5th and 95th percentile of the signal. So here we make an image of our electroretinography signal for adults. And here you also can see A wave, then it's B wave. So now here on the image you can see 50 signals, and this is a correlation, like let's say it's correlation image, and we see some birds of components, especially B wave. So this is abnormal signals. So this is the main task of such a report is to define norms of electroretinography signal for adults. So, and if you look on red marks, then you can see the diagnostic insignificant words. So it means, as I said before, at now moment all the clinical analysis A wave and B wave, A wave latency, and B wave latency, but not other waves. I mean, it's difficult to analyze because of artifacts, especially muscle artifacts. So that's what we did. So we define the median signal. Also, we define standard deviation here. And that's all about maximum error response, which I showed in my previous report. And we did some table which consists of median value of A wave and B wave. Also here is deviation standards, and here 5th percentile and 95th percentile. And also we define A and B wave latency. So next I want to show you something, which stay out of my report, but I think that's really important. So if you look at this picture, then we see the input signal. It has A wave and B wave, yeah. But we know that we have to do some advanced analysis. So that's not, the A wave, it means some Rhodes signal, and this is Cohen's signal. But as I said, as I showed before, the retina structure, it's really difficult. It's not just one cell or several cells. It's really, you know, it consists of cell structure. And we may analyze, you know, every cells or every cell structure on violet image. So here, this is the normal adult electroretinography signal. And here we see, here's the A wave and B wave, and here it calls oscillatory potential. So this is high frequency components of the signal. And this is A wave and B wave also on violet image. But let's look at adult signal with retinal rod dystrophy. And here we see some, you know, some difference. And that's mean, but you know, sometimes the signal, so this the signal looks the same, and clinicians may say like, okay, that's a normal electroretinography. But if you look deeper on violet image, then you can define that here's some abnormals. Another example, yeah, here. This is again normal signal of electroretinography, and this is adult signals with retinal rod dystrophy again. And look, like these parts of signal and these parts of signal, it looks the same. It's A, B wave, but we see that here oscillatory potential, so the high frequency components, it has less amplifier, and we see how the violet image is changed. So again, we may see that B wave is less than normal one. And it means this is rod dystrophy. So let's look at pediatric electroretinography. So this is the normal one. And again, we see, let's say, similar image, which has, let's say, the same it calls hot places, or yeah, let's say hot places. And here we see A and B wave, and also oscillatory potential. So, and here on the image below, we see the pediatric electroretinography signal with apparent distributors in electrogenetics in central part of retina. So it means our patients can't, let's say, can't see when it's dark, yeah, but he like see okay when it's light. And also here we see some difference, yeah. So the A wave looks different, but the B wave, it looks the same, yeah. So it means here we may analyze the rod and cone cells of retina. And another example of pediatric electroretinography. So here is the normal one, and here is cone rod dystrophy. So it's the worst case when patients can't see during light or during dark. And here we see the less amplifier for oscillatory potential, so the high frequency components of signal. And the last one is pediatric electroretinography with threefold decreases of B wave. So B wave is less, three times less than normal. And it's rod dystrophy. And look, image again different. So, but if you look, I mean, at the signal, you clearly can find A wave, B wave, and latency. And the main advantage of advanced analysis is that if we know exact frequency of cells of some, or combines of some cells, then you can find it on image, and you may exactly localize some cells, yeah, or some abnormals of cells functions and so on. So that's all. Thank you. Thank you.
Okay. Thank you very much for your report. And now let's ask some questions. Okay. Here you are.
What you can say about normal potential for our children, young men, or people that have problem with health, and no old people too? You understand me?
Yeah. So you mean some parameters of electroretinography signal. So as we know, our database has many examples of dystrophy. So the dystrophy usually when people get in older, all the retina cells, it's used in long period of time, and it means all or some cells may has dystrophy, and that's what happened. This is even if we look at adult patients. If you look at adult patient, that's the normal case. That's a patient probably 25, 40, sometimes 50 years old. So that's up of your habits. Some people try to do some gymnastics of eyes and so on, but who do this? Yeah, it's it's up to person usually, and up to what's your job. If you work on a PC or so on, then of course the dystrophy coming probably soon. And that's what happened. And sometimes it's influence on genetic. As I know about myself, so my father has rod dystrophy, and it means, and after 25 years old, I really feel that when it's dark, I have to focus on some details or on some objects. But for normal, if you look at normal signals, that's normal for both adults, patients. But we have to check, and that's what we did. We have to check that some components of the signal should be analyzed, but standard deviation and by median value. That's important. In other case, it's not a correct analysis. For some person, probably a wave, let's say 30 microvolt, it's okay, but for someone not. And we have to, that's why we need to analyze 50th percentile and 95th percentile. But for kids, for pediatric signals, that's really complex problem. So our database has only dystrophy signals. But if we look at another diseases, I think we have another picture of, especially of wavelet image. That's probably different.
Thank you. Next question, please.
Totally, I want to say that it was a brilliant study. Thank you for your presentation. But I have some question for medical applying, so medical application of this process. Tell us, please, how many patients have been studied?
Our database consists of 4,575 signals. Yeah, but we just analyze electroretinography signal, but we also have it calls visual evoked potential. So the electroretinography signal is recorded by your retina, yeah. But visual evoked potential, it's recorded by these places, yeah. And that's how we can analyze the nerve of eye, yeah. So and even some muscles. So we didn't analyze this part. So if someone interested in this field, so please contact me.
Yeah. Also, I want to ask you about what is the main pathology. As I recognize, it was a retinal dystrophy. Yes. Mm-hmm. So you haven't studied a patient with arterial hypertension or diabetic retinopathies because it's common problems.
Yeah, that's a really good question. Thank you. the database is really problem. So it's not electrocardiography signal, it's not electroencephalography signal. And to record single signal, you have to spend probably 20 minutes, sometimes 1 hour just for one record of one type of electrotinography. But it consists of 6 protocols. Yeah, so today we're talking only about one protocol, but we have to record 6 of them, and just single electrotinography tests for one patient needs few hours of clinical, and that's a problem. So I haven't seen any database of electrotinography before we published in IEEE Dataport. So that's the problem. So my answer is we didn't check another diseases because we haven't database, but we have a really good database for dystrophy rod, cone dystrophy, and another abnormal signal which has no diagnosis. I mean, it's also needs sometimes. We have to show the clinical, we have to check another tests, I mean, OKT and so on, and then define a diagnosis.
Thank you so much. And last question, is that expensive method for research or cheap?
I mean, for us, it's free. We are working with the Ravensburg Center, Microsurgical Center, and they provide us database for free. I mean, this is our multidisciplinary project. So they are all ophthalmologists, and we are engineering. So we are biomedical engineering, and we are working together. So actually, our scientific group consists the bioengineering from England, from Romania, 3 from Russia, and 3 clinical from Ravensburg Center, Microsurgical Center of eyes. Thank you.
Okay. Do we have questions? Okay, I think that's all. Thank you for your presentation. It was very informative.
Continue. And next speaker is Vitaly Nevezhin.
Hello, dear colleagues. I'm Nevezhin Vitaly. I present a review articles non-thermal effects of electromagnetic radiation, a living organism. Since the 2000, there has been a steady growth radioelectronic devices. According to World Health Organization data, the death oncological diseases in the world. Can you see it's 1990 for 2070 years, EMR is considered this as possible cancerogenic effects of human or living organism. Okay. I can see the non-thermal effects for human body, and next. Okay. Mobile phone is consists in direct contact with specific part, and one's human body of particular time. It leads its local effect of MRI and from radioelectronic device and specific area. Prolonged contact in central area human body leads chemoeffective in the tissues. You can see for these pictures, this program Synapse. You can try another mobile devices, and C is bone cells. Oh, it's heat. You can see, and gray and white matches bonds. Okay. The value is no specific effect. 2 watt of kilograms. It's not thermal effects. In not thermal effects of your mobile phones, it's and its beginner. It's thermal effects. It's thermal effects. It's using. Oh, it's not. It's next slide. Thermal effects. Complete medical devices. Can you try regenerative processes in tissues? They can motions blood circulars, and that's all. The study aims to analyze the current research on the considered it's not thermal effects. It's using of living organism. Can you show mobile devices, phone, and other devices? You can see it. Can you see of the effects of MR of living organism can lead to central changes in metabolic processes. You can see its mobile phone is on, mobile phone is off. The on processes is glucose level in smaller, but its activity process its motion. Okay. The process characteristics this images of underlying on seed of this and this endocrine systems. Okay. This slide shows the changes that occur the living organism under the influence of EMR in the cellular level. In addition, low energy exposed to radiation can also signal the simulation of action of sedative process in the body, which are characteristic by changes in the redox potential. You can see of this energy, this blockades for iron channel. You can see it's iron. You can, oh, okay. It's calculum or chlor and another. This slide shows the effect of IMRA in biochemical process in nerve cells. I changed the metabolic effects. You can see all this chemical process on this redox balances and these terms effects for per person of its schizophrenia and change of nervous systems and others. Okay. This shows the penetration for ability of MR dependence of age of person. The older person is shrinking these bonds on these contacts, on these penetrations. I present. Okay. This the old person have bone structures is another before its old child. Its old child penetration in electromagnetic radiation in about for this old. Okay. Sorry. Okay. Sorry. The picture shows its influence for okay. It's insulation of cell of membranes of myelin of destroyed for EMR. Myelin Okay. Relation of integer for which leads to change the passage of nerve impulse for emirate. There's nerve for cells and myelin for nerve channels. Nerve chip. Okay. The picture shows the influence for emirate to male reproductive system. The spermatozoid differ from oocytes but presents. Sorry. Yes, the effect of oocyte manifests of cells and international concept. For example, for attention, the cell wall and oocyte leads in impossible and fertilizations. You can see this gametes and highlighted. And another. Okay. As the picture shows the influence for emirate to males' reproductive systems, the spermatozoid differ from oocytes by presence or flagella. For spermatozoa, motor activity is important. Observe it is impossible fertilization for oocyte, not motion, not okay. Next, for oxidative process, can you see for this similar process about oocyte? A decrease in products of cell hormones leads to decrease of reproductive ability in the body, for man or woman. Okay. This slide shows the effects on the development of oncological procedures when it MRI is exposed to cell veil. For example, a change for electrical potential of a cell negatively affects and its availability. For this is intro of cells. This is intro for cells, but okay. Okay. Discover occurrence for DNA can accumulate, this can lead to developments or oncological. The main negative impact for MRI of oncological procedures, the simulation, which means that it is necessary to minimize the impact of MRI present cancer risk factors. Okay. Conclusion, you can see for this is present non-thermal factor for various systems, organism, its metabolic procedures, nervous systems, reproductive systems, and the simulation for oncological diseases. And okay, the safety for oncological procedures, you can each not to each, you can balance for you redox balance, and the save you redox balance, you save your life. And okay, thank you.
Thank you for your presentation. And now, questions? Okay.
Yeah, thank you. So, can you simplify for me? Is a mobile phone dangerous?
Not to mobile phones. It's mobile phone can kill cumulative effects. You 1 hour is it's safety, but you can 1 year, 2 years. You can check for this. Is mobile phone radiation and penetration for you reproductive systems is.
How long does it take for mobile phone to affect my body?
Effect of body. it's a different question. It's different. It's different questions. But I think 5 years needs for discharges for normal processes or your organs contact for mobile phone.
So as I know, mobile phone is in our lives more than 5 years. And is there any like research which proves that it is really so dangerous?
Your phone can CRR. You can, you know, for CRR. Your mobile phone CRR maybe okay. My mobile phone can CRR 1 watts kilograms, but this is not too safe. You need to show your mobile phones is technical documentation. Can you information? Yes, general information for. Huh?
So if we take like general, not mine, but like some average, average mobile phone, like how long does it take for it? Okay, I understand it's complicated. Okay.
Question. Thank you for your report. And I have one question. Can you differ effects to mind and nervous system in mobile phone? Because I think insomnia and some effects of cognitive and emotional depends on internet, but not radiation of mobile phone.
What does it mean?
I think that insomnia and depressive symptoms, anxiety, and other effective decrease nervous system can depend on social
communication.
Yes, communication, social communication, but not mobile phone radiation. Can you differ this?
I think maybe it's my opportunity. Mobile phone, the contacts, maybe you tissues can take this. Contacts for bones, maybe muscle cells and nerve cells, but nerve cells it have the electrical potential. Potential. Okay. It's bigger structures for brain. Its biggest structure very okay. The biggest structure biggest accumulates for EMR is EMR not so like that. Yes, it's for not it's no it's and for this.
So for like Ridel, not special demand. It's for us with
So can you for the definition?
Really, sure. Then the result of the site, it's dangerous for DNA, cells, membranes, then
And another, for this, bigger, maybe 1, 2, 3, and another, but brain, it's important for
You mean if the stuff, if you have million and then solves the control?
Million structure for them.
Okay, sorry. Million, it's million structure. It's safe for nerves analysis. Okay, it's the safe. The safe for you, the safe nerve cells analysis for up radiation.
No questions, yeah? Okay, let's start with the last question. Two last questions, and after that, some comments.
So, thank you for your presentation. It's a very discutable topic, but I have some questions. So, the first question, you say that patients, as I understand, you examine patients, yes?
What does mean examine?
You study patients. You have studied some patients, yes? So you complete their anamnesis vitae. Anamnesis morbi means history of life, history of disease. So medical research. Tell us, please, do studied patients have concomitant diseases which can lead to demyelinization of the nervous tracts, such as diabetes mellitus or chronic alcoholism or I don't know, some cirrhosis of liver or something else? Because those diseases, they lead to demyelinization of nervous tracts, nerves. So, and they can make some influence to your results.
Can you repeat the question?
Do studied patients have any diseases? Some diabetes mellitus first, second type, or alcoholism chronic, or any liver diseases, or something else?
Okay. Oncological disease.
Which type of oncological disease do they have?
Isosomia and another. Yes.
Okay, I think we can continue our discourse after our conference, after our section, because we have a few time for other reports. Thank you so much.
Around 2010, there was an increasing demand for 4G networks.
I had some big concerns regarding LTE. Vodafone Germany is operating 4 networks. Unfortunately, the worst case would be to add now with LTE network number 5, LTE 800 and network number 6, LTE 2.6.
当时是我们和客户讨论，觉得原来传统的建网方式的话都是重复建设，所以成本也很高，维护也很复杂。
So we talked with our customers again to see if we could combine 2G, 3G, and 4G network equipment into a single unit. That's when Single RAN was developed. According to our customers, this was a very attractive technological invention.
Our vision is giving all of our customers 2 years from now broadband data coverage where we do have voice coverage today. That means countrywide.
In 2010, the 4G LTE 800 MHz commercial service was first launched in Germany. The 800 MHz spectrum is best suited for the vast countrysides of Europe.
In these so-called white spots, outside, in the countryside, in the small villages of Germany, hey, now it's really fast internet in my hands.
Anastasia Cheremiskina.
Hello, dear colleagues. My name is Cheremiskina Anastasia, and today I would like to present you a presentation, laboratory preparation of biosensor based on silicon nanowire field effect transistor for virus indication. Any thoughts? Okay. A biosensor based on silicon nanowire field effect transistor is a modern device which allows one to indicate single biological macromolecules and viral particles. The biosensor structure consists of a silicon substrate on which a silicon nanowire is located between the contact areas of the source and the drain. Biosensor has such properties as high sensitivity, selectivity, and ability to conduct experiment in real time. Next slide. In the process of indication, an antibody virus complex is formed on the surface of nanowire. It changes the current in the source drain secured in the transistor. Тогда next slide. Also? Еще? Еще, пожалуйста. Next slide. If we want to create biosensor with high selectivity and sensitivity, we should choose such preparation conduction that self all the elements of biosensor and activity of antibody. So the goal of research is laboratory preparation of biosensor based on silicon nanowire field effect transistor for virus indication. The first task, search for promised method for removal contaminants and create a cross-linked layer on the surface of nanowires. And the second task is attachment of antibody to nanowire. Next slide, please. Let's consider the first task of the study. On the slide, you can see a step-by-step scheme of complete this task. At the first, we remove fatty compounds and mechanical particles using absolute ethanol and distillate water. When compounds that chemically bind to the surface are removed, use 1 or 5 from solution. They you can see on the slide. After that, the surface is washed in stream of distilled water and dried at room temperature. When compounds are removed, a cross-linked layer is necessary to create. This layer serves as a basis for attachment of antibody to the surface of a biosensor. For it, we use free solution, which you can see on the slide. Next slide. Next. Analysis of the surface after removal of contaminants was carried out by atomic force microscopy. The minimal size of the surface roughness and falling particles, as well as the safety of the elements of the transistor, were considered the efficiency criteria. The result of the analysis after removal of contaminants you can see on the slide. Can you... Next. As we can see, the most offensive method was sequential use of ethanol and solution consisting 1 part of hydrogen peroxide and 3 parts of water. Next slide, please. Analysis of the surface after creating of cross-linking layer was carried out by atomic force microscopy too. Among the free solution used, 7% of tests in absolute ethanol is most suitable. As a result, next, please. As a result, a relative homogeneous FTS layer with a small number of oligomer regions is created. Next. Second task is attachment of antibody to nanowire. For this purpose, suspension of antibodies with the reference concentration 125 mg per milliliter was diluted in 10, 100, and 1000 times. Next, a suspension of antibody without dilution and pre-preparation solutions were applied to surface for 2 hours. After it, we washed the surface with distilled water and dried at temperature, at room temperature. The FAS and criteria were considered the creation of homogeneous monolayers of antibody molecules in the surface. The most effective way to use them was dilute in 100 times. Next, please. Next. In this case, a layer with a roughness of 10 nanometers and a particle's height of up to 30 nanometers was observed. The particle size is explained by the probably creating of antibody amount themselves. Next, please. I'd like to finish by emphasize the main point. At first, the using of solution one part of hydrogen peroxide and 3 parts of water is the most effective method for removal of contaminants, and use of 7% of test in ethanol, absolute ethanol, is good to create by monolayer. That's all. Thank you for your attention.
Okay, thank you for your presentation. We have a very few time, so we will ask only 2 questions, okay? Because we want to finish our section today, so... okay.
Thank you. So, can you tell us, I mean, we know from previous presentation that plasma consists of antibodies, plasma. So, as I understand correctly, do you, do you put, do you analyze antibodies based on plasma using your biosensor?
For preparation of biosensor, we use antibodies which we do.
What do you exactly put on biosensor? Plasma, blood,
No,
what?
It's clean antibodies, suspension of antibodies.
Answer, I think we will finish with questions.
Next speaker is Tatiana Rostovskaya.
My name is Tatiana Rostovskaya. I'm from St. Petersburg, and I'm not an engineer at all. I am a surgeon, a phlebotomist. Actually, that's a doctor who mostly care about veins on patients' legs or lower extremities. So today I want to talk about the efficiency of using the thermal imager on these patients, including telemedicine. Next. And next. The point of view is that in some regions, for example here, I suppose there is no such doctor as phlebotomist, but I suppose that it's a really common disease. There is a lot of patients who need his help. So sometimes that patients even don't have an opportunity to do an ultrasound scan. And this study was started with this thought that maybe we can do something else. For example, telemedicine consultations, but what for surgeon actually just pictures or words, symptoms, not always enough. So we have something else. Next. We took 30 of our patients that was examined, and some of them already was treated in our clinic, and show their cards for the expert who there were 15 patients with varicose veins who needed treat, and 15 patients without varicose veins but with some aesthetic problems that not actually clinically important, but we could do something from the aesthetic point of view. Next. So an expert saw 4 pictures of each patient in 4 angles, and he had to make his decision if this patient needs to have an ultrasound scan, and so the operation after that. So he needed 2 classified patients with international classification CEAP, and after that decided if these patients go to the ultrasound or not. And this ultrasound scans was limited by 15. Next. So actually that's how it looked. If you see on the right leg, in the inner side, there is blue bumps. This is actually what varicose vein is. But it's not always so obvious. Sometimes, for example, on the obesity patients, we cannot see this just by image. Next. And there was the second stage when the expert had 4 images and also 4 thermographies. So he needed to do the same, but with more information. Next. That's how it looks. And so this is, I think, much obvious on the right leg. And also now we see that there's some problem on the left leg too. The red regions, it's very basic. Varicose veins, it's dilated superficial veins. And blood in that veins comes directly from the deep system, so it's hotter than the surface of the skin. And just what we see, this is it. Next. So as a result, we had 2 groups of results, one just with pictures and the other pictures and thermographies. And there were some mistakes when an expert evaluated just pictures. Next. And when we had pictures and thermographies, there was everything fine. So I think that it's pretty useful, and according to the simpleness of this study, and that it cost just like the thing that we used is putting on the button of the phone and just making picture thermographies on your phone. It's costs like 4,000 rubles from China, and not an ultrasound scanning machine. You need the certificate to use also. So that's it. Thank you for your attention.
Okay, thank you for your report. Okay, yes, thank you for your report. We have questions, yes? Okay.
Thank you. A few weeks ago, I have been talking with a doctor from United States. He's originally Russian, and he showed me a device. It's like ultrasound device, the small one. It calls Butterfly, and it's connected to his iPhone, and then he can check the image. So it cost about 3,000 US dollars. How much in rubles?
That's not much.
That's not much,
Samsung
and that's really useful. And he said like the accuracy of image and even all the parameters. It's enough.
I work with things like that, but it's still more money. And this what you need the certificate for example.
It has only CE
ultrasound
certification.
Certificate.
It's not certificated in Russia.
And also we don't have. Thank you.
Okay, let's small, very small. Okay, I believe you.
one question, if you want. Which symptoms patients present to you, or they was asymptomatic?
This was different patients. The excluded moments were that they don't have acute infiltration, thrombophlebitis or something. It was patients with C2. It is when they just have varicose veins that we see. They don't have any traffic changes on the skin. So it was just like the skin and varicose veins. You see, not see, and sometimes you don't see on image when they are there. So that's the point. But in future, actually, this is very useful thing to diagnose also trophic changes, and that's what is doing in diabetic practice, in some altars, healing, and so far. So it's not just like, oh, we found this.
You. I think your report was very, very interesting.
Next speaker, Anton Dolganov.
So, greetings everyone. My name is Anton Dolganov. I'm from Ural Federal University, and today I'd like to present my report. It's kind of my side project that I'm doing in kind of spare time from doing some other stuff. It's titled Application of Neural Networks in the Problem of Indirect Estimation of Blood Pressure using Heart Rate Variability Features. Next slide, please. And next. So this is the summary of my presentation. First will be rather not very brief introduction to the problem, some prehistory of it, then materials and methods used in this particular study. So datasets, some preprocessing of features, neural networks, results, and conclusions. Oh, great, finally. So this kind of work grows from my PhD thesis. And in my PhD thesis, I was working with signal of heart rate variability. What is heart rate variability? Well, I think everyone knows what the electrocardiogram is. It's the most famous signal of the heart. Everyone knows it sounds like beep beep in surgery. And the heart rate variability is like the interval between two big peaks on this electrocardiogram. And what's great about this heart rate variability, it's very easy to measure, and it has very good associations with reaction of the person to different functional laws. So my PhD thesis was about processing these signals under certain laws. In particular, it was tilt test when patient was moved up by like 70 degrees for several minutes and stayed in this condition. So, overall, my PhD study was about processing these signals and finding the differences between healthy patients and healthy persons and patients with arterial hypertension and maybe with some other pathologies. And, well, brief story, I was able to make such classifier that classifies healthy from arterial hypertension using only the data of heart rate variability features. And additionally, it was found out that my metrics that I get from these heart rate variability features has moderately good correlation with the change of the blood pressure within these patients. So after that, I have decided, well, what if I try to predict what will be the exact value of blood pressure using only these features of heart rate variability? This is kind of some projects I am having for a while, for like third year. And first I used like basic machine learning methods, basic like genetic programming, and reached some modest results on this problem. But overall, the results were kind of as follows. I was able to predict the change of the pressure. So if I know at the previous time signal, I can, with like 10% error rate, predict what will be next. So the goal of this particular work is to try to use the modern neural networks in this step in the simplest form, just fully connected neural networks for this task, and to basically compare different architectures of neural networks, how they influence the performance of the task. So first, it all starts with datasets, and for that I'm kind of lucky. It's not eye-related signals, it's ECG, and there are a lot of publicly available datasets for that. In particular, I used one where there are a lot of simultaneously recorded signals. But the problem with such open datasets that they are not always clean. And for that, I had to do a semi-manual search of clean 30-second signal segments without some disturbances, basically like this one. So then, as it is generally done in machine learning, everything is split in a training data in which you train, and then test data, which is not shown to the neural networks to show how your model behaves on a new data. And overall, I have like over 2,700 segments for training and like almost 700 for testing my models. So as for features, I have extracted like generally accepted features of heart rate variability and some special revolved around wavelet transform. Overall, I had 64 features of heart rate variability. Great. So now, as for neural networks, I used as a foundation TensorFlow interface because it's very easy to implement. It's nice to live in 2021 because there are a lot of libraries which implements most of the stuff for you. You just need to pick a correct one. And I have tested basically different variations of what will be in the hidden part of the neural networks, number of layers, or should we use something like bottleneck structures with decreasing number of layers, and so on. But the input was always 64 features and output 2 values of pressure, systolic and diastolic. So this is kind of summary of all results for different architectures. Well, basically, most of them reach almost the same level of precision. Like for systolic blood pressure, the best results was median error of like 7.5%, and for diastolic blood pressure, like 10% of error in absolute units. And it seems like the best architectures was simple, like ones having same number of neurons. So, in conclusions, that I would like to point out that now my model are able to predict blood pressure using just this data, well, with certain mistake, but now I don't need this calibration-like adjustment like it was needed in my previous models. And some plans for the future, like to use technique called transfer learning, maybe to find a bigger data sets with more features to train like for feature extraction, well, because it's kind of this paradigm works for image classification, and just train the last layer for my specific task of predicting blood pressure. So that's it. Thank you for your attention, and I'm ready to answer your questions.
Oh, we have a microphone and we have a question.
Thank you, Anton, for your presentation. I understand you are a kind of expert in heart variability and pressure. So I am actually a developer of pulse oximeter. If you know, we also try to detect heart rate variability. So is it possible to determine the pressure from the pulse oximetry signal, for your opinion?
Well, actually, I have seen a lot of, I have studied several review articles on this topic of these indirect estimations, and I think your signals is also mentioned there, so I think there is a possibility, given a right data set, given enough data, so I would say there is such a possibility.
Okay, I hope we have a question. Oh, yes. We have no question. Thank you very much for your report. The next.
My name is Rahmatul Fagimович. I'm a candidate of medical science, a doctor cardiologist, and I'll tell you about visualization of a digital twin of the heart. So let's start speaking about this topic. So this study considers methods applying of computer graphics for visualization of electrical activity of the heart based on such algorithms for topological transformation and voxel representation of three-dimensional heart model. So we have distinctive feature of proposed approach, and this feature is which is spring voxel is a unit volume, so which is a medical model of a heart muscle cell known as cardiomyocyte. Visualization of heart activity represents a task of synthesis, a three-dimensional model which displays spreading of the atria and ventricles excitation according to readings of an electrocardiogram. So, as a clinician, I can say that there are a numerous cases of clinical situations which we can use this digital twin technology. So, the first one, it can be different cardiac arrhythmias such as atrial fibrillation, atrial flutter. Also, we can use it in acute and chronic coronary syndrome, which is also known as acute and chronic ischemic heart disease or coronary artery disease, and also in acute and chronic heart failure. So here we can use some goals, such as productive for description of electric heart activity. I will use it as a HEHA. We use by proposed model by L.A. Titomir, concept of equivalent electrical generation of the heart, WEGH. So according to authors, functional capabilities of electrocardiology are expanded due to synergic interaction of WEGH of dipole and surface type. So on the second figure, it shows some diagrams of active workplace, optimized workplace of cardiologists, and digital twin of the heart. So the most important element of AWP of a cardiologist, it is, as I said previously, it is a digital twin of the heart. So which analyze and visualize the electrical activity of the heart using electrocardio signals of multiple leads. So it can be a standard 12 leads of an ECG, or it can be assessment of multiple leads, which we also make assessment of in our previous works. And also it is interaction between elements of AWP of cardiologist and digital twin of the heart. So if we talk in general about implementation of the digital twin of the heart, it should provide some features. So the first one, it should translate from ECG maps to the surface of the torso and WEGH maps on the surface of the heart to assess spatio-temporal dynamics of conduction of the excitation of the myocardium, so the cardiac muscle. Also, it should provide transition to the spatio-temporal characteristics of the WEGH of dipole type in the volume of the heart for diagnosis of ischemia. Ischemia, it means decreasing of the oxygen supply in the myocardium. Also, we can use it and it should provide predicting for treatment of heart disease based on joint use of equivalent electric generations of the heart of the surface and dipole types. At the same time, if we consider a process of visualization of a digital twin of the heart, then we should think that heart is a complex graphic three-dimensional object. Also, as you can see on the screen. Obviously, that synthesis of a complete model of the heart, known as a computed model of the heart, meets requirement of functional possibilities and computational costs. And these two parameters, they are the most important condition for increasing of efficacy of the cardiological diagnostics. So on the bottom side of screen, we can see the visualization of excitation spread in the presence of damage area. So this picture we can see on patient with arrhythmias which appears by re-entry type. So key moment of this pathology, impulse of excitement passes, but some part of cardiomyocyte turn temporarily responsive for excitement, and it's known as term as refractoriness. So it's unable to excite. So based on foregoing, using of proposed model and changing of its parameters in visualization of excitation is necessary for. The first one, it is modeling of different spread excitation types in the heart. Also fixation of a form change in of transmural action potential for different parts of the heart, because different parts of the heart have different action potential, also such as atrium, AV junction, also ventricles. Also we can determine myocardial excitation speed, and we can visualize electrical mapping of the heart, and we can detect areas of ischemia, of necrosis, and it helps us to differentiate different clinical conditions. So methods of imaging and methods of proceeding of electrocardiogram signals of multiple leads provide an ability to determine, without distortion of spectrum of spatial distribution of an electric potential during transition from the myocardial region to the surface of the torso. And a essential point to improve, clarify of diagnostic, it is ability to display WGH by surface type maps in a dynamic model. Also, it's synchronously with ACG in one of standard leads. So here we can use different standard leads. So in the 12 lead standard ACG. So conclusion, we can say that combination and integrated use within a framework of a computer diagnostic system for analysis of cardiac information, modeling and visualization of the heart condition requires new approaches and solutions to construction of computer diagnostic system. So this study shows that visualization of electrical activity of the heart is the most important condition for increasing efficacy of the cardiological diagnostic and treatment. Also, since ambiguity in interpretation of ECG and low level of visualization of results obtained reduce effectiveness of diagnosis. So as a clinician, I also can say that it is important first to diagnose some cardiac disease, but it's help us to fight against complications, which leads to patient deaths, and the diagnosis of cardiac disease leads to decreasing of mortality in different groups of patients. So thank you for attention. Any questions here?
And we have questions.
Okay, thank you for your report. Did I understand you right that the input for this technique is ordinary ECG, and then it's just a smart software which makes a model of what?
Thank you for the question. Yes, the input for this imagination is just standard leads of ECG. So we're collecting the electrocardiac signals from the heart activity, then we are representate them into the unity model, that's a three-dimensional model, and then we can make assessment of the cardiac activity in the real time. You're welcome.
Thank you. Thank you so much. And I mean, usually cardiologists analyze ECG signal based on several standards. I mean, 5 leads, 12 leads, and 3 leads, I suggest. So is it possible to, to change, I mean, from 10 to 12 to 5, I mean, like this?
In our case?
Yeah.
In our case, yes, it is important, but if we have increased number of leads, we have them detailed diagnostic information. So we can use 12 standard leads, or we can use 24 or 100 leads. So as a patient's body surface can help.
But at now moment, what is limitation? I mean, how much leads or we can?
Limitation is surface of patient's body area.
Okay. Yeah, thank you.
Thank you so much.
Thank you.
Next.
Next speaker is Aryuna Banzanova.
Good afternoon, dear audience. My name is Aryuna Banzanova. I am a student of National Research Tomsk Polytechnic University, School of Non-Destructive Testing and Security, Department of Electronic Engineering. The topic of my presentation is optical vibration method for studying the process of agglutination of red blood cells. A properly defined blood type is extremely important for a person's life. A blood group characterizes a set of antigens located on the surface of red blood cells, which determines their specificity. There are a huge number of such antigens, but the most significant ones in the blood transfusion are the antigens of the RH factor and the ABO system. Red blood cell agglutination is a biochemical process of aggregation, gluing, and precipitation of red blood cells occurring in vitro or in vivo. Determination of the blood group with the help of silicons helps to get the fastest result. The method doesn't require long sample preparation. Whole blood and reagents are added to a special tablet on the required ratio. After 3-5 minutes of constant stirring, the result will be ready. Existing analyzers have large dimensions and are used for laboratory research. Therefore, in emergency situations, the blood type is determined manually. According to the Pirogov National Medical and Surgical Center, about 1% of the results are incorrect when typing blood by manual method. We propose an optical method for studying of the agglutination of red blood cells. During agglutination, the studied environment is enlightened. When developing the method, we encourage a problem. When we use the flat cuvettes due to the agglutination fluctuation, the change of the light flux is insignificant, as you can see at the slide. Thus, we decided to use the drop sample, since the drop has the shape of the hemisphere, it was focusing properties of a lens. To register the absence or presence of agglutination of red blood cells with the help of silicons, the method of photometry of drop sample was used when creating mechanical vibration in them. The study was carried out as follows. Sample of whole blood and reagents were added to the cuvette. In the presence of agglutination, the sample was eliminated. The intensity of the light flux increased. The graph you can see at the left side on the slide. In the absence of agglutination, the sample was clouded. The intensity of the light flux decreased, as you can see at the right part on the slide. The vibration extent of the sample helped to accelerate the agglutinational process. After about 20-40 seconds, it was possible to get the result. We concluded studies on more than 70 samples of different blood. Graphs of curves in the presence or absence of agglutination behave similarly. In the presence of agglutination, the sample is eliminated and there is an increase in the output voltage. In the absence of the reaction, the environment becomes turbid, and the study has shown that the proposed method can be used in automated devices for determining the blood group. That's all. Thank you for your attention.
Okay, thank you for your presentation. Do you have any questions? No questions. And oh, thank you very much. Okay, next.
Good evening. I present you notation with topic of scientific work, development of radio frequency ablation device with simulation determination of the transmural effect achievement. Radio frequency ablation is one of the most commonly used and effective treatments for arrhythmias of various types. The essence of the method is in the destruction of areas of the myocardic through which pathology impulse active is conducted. Destruction is carried out by sampling radio frequency energy to areas of the myocardic from a generator using a special tool with electrical contacts. As a result of destruction, the abnormal propagation of implies stops. Currently, the existing scientific approaches with determining the achievement of the transmolarity effect of biological tissue are based on measuring the temperature in the area of the electrodes and the conductivity exposure between the electrodes. First, measuring the temperature in the area of the electrodes exposure in the complication of the tool design. Second, measuring the conductivity between the electrodes is the lack of a control over the rate of change in conductivity. There is a way to control the ablation device by choosing the value of the applied power. The main disadvantage of this method and the device is that for a different volume of tissue between the electrodes of the instrument, it is necessary to supply different constant power. The device that I am developing has increased measurement accuracy and production costs have been reduced. New circuit solution of a radio frequency ablation device with a simulations determination of the achievement of a transmural effect is proposed. An algorithm for the function of the system to determine the achievement of a transmolarity effect, capable of controlling additional parameters has been developed. The slide shows the development and design model of a device. The apparatus consists of a generator and tool. The device generates energy which through the connector of a body transmits through the cable to the instrument. The device, by monitoring the impedance of a tissue according to a given algorithm, estimates the parameters that change in the characteristics of the tissue, and when a complete damage to the tissue is researched, it stops supplying energy to the instrument. It informs the doctor by sound signal and displaying the graph of tissue impedance change of monitor of a device. The proposed algorithm will allow to obtain a better heighting of the layers of the tissue when that of analogous. The principle of its operation is follows. As the tissue temperature increases, impedance decreases. Power should be reduced to avoid overheating the tissue of the surface. As the cells begin to break down, impedance increases. Power should be increased to maintain the rate of work. A prototype of a radio frequency ablation device with the simultaneous determination of the achievement of a transmural effect which makes it possible to increase the variability of the formation of non-conductivity tissue areas, which in turn helps to reduce the operation time and increase the effectiveness of the ablation procedure has been developed. So thanks.
Thank you, Vladimir. I hope you hear me. Do you have any questions? Okay, we have a question.
Why do you use frequency 440? Repeat. Не слышно?
Oh, okay. Vladimir, do you hear me? Yes?
Yes.
Okay, we have a question.
Why we use frequency 440 kilohertz?
440 kilohertz.
Why? Do you try use other frequencies?
How you find transmural place of myocard?
Repeat.
How you find transmural place of myocard?
When energy passes through the tissue,
Okay, thank you. Thank you, Vladimir. And it was the last report of our section 3, section 6. What?
What is NSTU? Novosibirsk State Technical University is one of the largest technical universities in Russia, located in the very heart of the vast Siberian region. It might be called a city within a city, not only because of its size and infrastructure, but the special rhythm of life influencing emotions of thousands. NSTU guarantees advanced education, offers a vast variety of programs, and is proud of its highly qualified faculty. It provides stimulating ground for the students to acquire knowledge, develop skills, and understand the beauty of the world in its diversity and multiplicity. NSTU is innovative and research-oriented. It is a place where breakthrough discoveries are made to contribute to intellectually challenging fields of study and world-class scientific projects. NSTU enjoys freedom of creativity and thought. It offers both students and staff the opportunity to express themselves, to maximize their talents and give way to imagination. It allows them to get surprised and surprise the world, broadening horizons and seeing new things in what seemed only common and ordinary. NSTU is born to be a winner. Its faculty does their best to educate high achievers who understand that soaring to new heights involves strategizing and hard work.
The desire to win is the first step on the way to success. NSTU is your career. It offers new contacts leading to lifelong friendship, positive emotions, and love. It fills your life with meaning and gives unforgettable experiences. NSTU is people. NSTU is you.